How are you, my friend?
Good.
You're gonna be even better in 10 minutes. All right, have fun.
Thank you. As we know, we use energy every day. From powering a house to running a large factory, energy is something that we just can't do without. But currently, 91% of all our energy is being produced by unrenewable energy sources, which will eventually run out, quite possibly even before this century ends. With time running out, we need to find new ways to save energy in our everyday lives before it's too late. For this reason, I invented Tec Tricity. Tec Tricity is a phone case aiming to save energy and reduce cell phone power consumption by using piezoelectric plates to harvest energy from taps on a cell phone. Tec Tricity converts mechanical energy from texting into electric energy used to charge your phone, so you can use your phone to charge your phone. Tec Tricity converts mechanical energy from phone taps into electric energy used to charge a phone by piezoelectricity, discovered by Jacques and Pierre Curie in 1880. Piezoelectricity takes advantage of the asymmetrical atomic arrangement of ions in certain materials. When subject to pressure, these materials will accumulate charges on either ends, resulting in electrical current, and achieving the effect of converting mechanical energy into electric energy. My first application of these piezoelectric materials involved a cardboard phone case, but the cardboard phone case was not rigid and very inefficient at collecting pressure for the plates. So I used 3D printing to make a rigid and efficient phone case that also allowed me to precisely map piezoelectric plates on ridges to maximize bending and produce the most power. I used the metal plate to secure the piezo plates in place and also to evenly distribute pressure. The electrical components, which are used to convert the high impedance output from the piezoelectric plates into current suitable for charging a phone, are fitted on the bottom side of the phone case. One of the biggest design challenges in Tec Tricity were the circuitry design. So in my initial prototypes, my circuitry consisted only of piezoelectric plates generating 50 volts AC at about 80 microamps, a bridge rectifier to convert AC to DC, and a capacitor to smoothen out current. But as you can see here, the current output now at 1 to 10 volts at 200 microamps is nowhere close to being able to charge the phone. Imagine this: the internal phone charging circuitry, which is required to be passed through in order to charge the phone, is like a pressure control valve, which requires a lot of pressure to be able to push through. And the piezoelectric plates are like a low pressure water supply, whose pressure is nowhere close to being able to push through the pressure control valve. So I used a pressure tank, or a power bank, to allow the accumulation of water to be sprayed out in a concentrated stream. After using a power bank, I was able to get a 740 times improvement of current output. But this was still not enough. So first, as you can see here, the nominal current from the piezoelectric plates were inefficient for charging the power bank. But also, the current output now is 3.7 volts at about 200 milliamps, is still not enough for charging the phone. So first I used an energy harvesting chip, which is used for its LDO buck controller to regulate voltages at ultra-low currents and allowing the output from the piezoelectric plates to enter the power bank. I also used a boost converter, which is used to boost 3.7 volts at about 200 milliamps up to 5 volts at 1 amp, ready to charge the phone. To better understand this, the energy harvesting chip acts like a sink for regulating water flow and allowing the water to flow from the dripping faucet into the pressure tank. And the boost converter acts like a high pressure hose, which allows the water to be sprayed through the pressure control valve and enter the water storage container, or the phone battery. So now I will do a brief demonstration of Tec Tricity in working. So this is Tec Tricity, and the phone is inserted inside. The piezoelectric plates and the electrical components are fitted behind the phone. So for demonstration purposes, I've used Tec Tricity for about 5 minutes prior to the presentation. And now when I flip the switch, the accumulated charge from the piezoelectric plates are used to charge the phone. And as you can see here, after multiple stages of regulation and conversion, Tec Tricity is capable of charging the phone. So these are the materials I used. The 3M materials that I used included a 3M Scotch weld, epoxy, and acrylic adhesive that helped me attach all my phone components to the phone case. Currently, Tec Tricity is a proof of concept that we can recycle wasted energy in our everyday lives. Going forward, I would like to engineer a new transparent piezoelectric material to make an energy harvesting phone screen. And I would also like to use PCB printing to make a compact and efficient chip for the circuitry. I hope that in the future, Tec Tricity can make an impact on renewable energy. Also, special thanks to my mentor, Dr. Daly, and all of the following people for making this project possible. Thank you.
All right, Theo, I'm curious, how long will I have to text on my phone to charge my battery? And how might you find that information? So
currently, Tec Tricity is mainly a proof of concept. So right now, the phone is capable of extending battery life for about 1% throughout an entire charge. So I hope that in the future, after using a piezoelectric material for an energy harvesting phone screen, I can significantly improve upon that number.
Theo, have you thought of other applications of the piezoelectric energy harvesting that your approach could be applied to?
I definitely think in addition to phones, we could definitely use it for tablets and iPads, and also possibly computer keyboards. So,
Thank you.
Thank you, Theo. That was great. I'm wondering, you had several times where you did your tests and it didn't come out the way you wanted.
Yeah. And
then you had to change it and you had to start again. So what was the most surprising thing you learned throughout this process?
so I think the most surprising thing that I learned is that with every experiment, it's like 99% failures, and it's like that 1% that you get it to work. Yeah.
Hey, thanks for the analogy to the water and water pressure. How did you find out about these electronic components that could boost the power and actually get the phone to charge?
I did a lot of research. So through a lot of research and also the help of Michael Griffin, I was able to find the correct components in my final design to help me get all the components to work.
Are there similar inventions out there?
So I've looked into piezoelectric energy harvesting, and there is currently a energy harvesting shoe, but I've not found anything similar to a phone case.
Would you just help me identify the 3M products that you used and how you integrated them into your innovation?
Yeah, so the 3M products that I used included a epoxy and acrylic adhesive. So the epoxy has like a good strength because I needed the piezo plates to be able to like be on ridges and like not fall off. So that really helped me attach my piezoelectric materials and also my electrical components.
What led you to this topic in the first place, Theo?
So I've always liked the idea of recycling energy. So like recycling energy that we use. So like I know that phones are like we use phones all the time right now. So I thought it would be really awesome to like create something that could recycle energy wasted by phones.
Do you know, or can you tell us more about what exactly is the piezoelectric material that you're using?
So the piezoelectric material is made from quartz. The plates that I'm using right now are made from quartz. So they have like an asymmetrical atomic region of ions. So like geometrically, when they're like at rest, they'll be in balance. But when you push them, they get deformed and the balance is broken. So it creates charges, which is what creates the electrical current.
Theo, did you test your prototype with anybody? Did anybody use it and give you any feedback on how it worked for them?
Currently, my prototype can generate about like 4.8 microwatt hours per phone tap. I have not done any tests for people, but I think it would be more successful in the future. So.
I think you were onto something, my friend. That was very good. Feeling better now?
Yeah.
All right. You did a great job. All right, make your way out there as I give you another round of applause.